Take a look at your breakfast table: a glass of milk, a warm cup of tea, maybe a bowl of cereal with fresh fruits. Looks simple, right? But here's a question for you. Is that milk really pure? What about your tea? Is it just one substance or a mix of many? Most of us would say, yes, it's pure. But science has a different story to tell. In this video, we are going to explore a concept that's all around you, in your food, air, even the water you drink. Let's dive into the fascinating world of mixtures. Now, let's break it down. What exactly is a mixture? In science, it's not just tossing things together. A mixture is a blend of two or more substances. But here's the twist: they're not chemically combined. Each component keeps its own identity. You can separate them by simple physical methods, no lab coat required. Think about this: when you stir salt into water, does it become something new? Nope. It's still salt and water, just perfectly mixed. That, right there, is the essence of a mixture. Now that we know what a mixture is, let's go a step deeper. Mixtures come in two main types, and spotting the difference is easier than you think. First up, homogeneous mixtures. These look the same throughout. No matter where you look, it's uniform. Take salt dissolved in water. Can you see the salt? No. It's completely mixed, and you can't tell one part from another. Next, heterogeneous mixtures. Here, the components are clearly visible and not evenly spread. Think of oil floating on water or sand mixed with iron filings. You can spot the difference right away. So, how do we tell them apart? Simple: if it looks like one thing, it's homogeneous. If it looks like a mix of things, it's heterogeneous. Alright, let's wrap this up with a quick look at the key properties of mixtures, and trust me, these are super easy to remember. First, the substances in a mixture are not chemically joined. No new substance is formed. Second, you can mix them in any proportion. There's no fixed recipe. Third, mixtures can be separated using simple physical methods like filtration, evaporation, or even sieving. And finally, each component in a mixture keeps its own identity. So, what does that mean? It means your salt still tastes salty in salt water, and iron in a mixture with sand? Still magnetic. Pretty cool, right? Mixtures are flexible, useful, and all around us, and now you know what makes them so unique. Time to put our knowledge into action with a quick problem. You have 40 grams of salt and you mix it with 160 grams of water. So, what's the total mass of the mixture? Let's break it down. Step 1. Use the formula: mass of mixture is equal to mass of solute plus mass of solvent. Step 2. Plug in the values. That's 40 grams plus 160 grams. Step 3. Add them up. 40 plus 160 equals 200 grams. So, the total mass of your salt water mixture is 200 grams. Simple, right? Mixtures are all about combining, not changing, the substances involved. Let's put your understanding to the test. Ready to classify a few mixtures? Take a look at this chart and follow along. Soda water. It may look fizzy, but it's actually a homogeneous mixture. Why? Because carbon dioxide is evenly dissolved in water. Soil, definitely heterogeneous. You can see and feel different particles like sand, stones, and organic matter, not uniform at all. And what about milk? It looks smooth and uniform, but surprise, it's a colloid. That means it's technically a heterogeneous mixture, just with very tiny particles. So next time you sip a drink or touch the ground, think like a scientist and start classifying. So, what have we learned today? A mixture is simply a physical blend not a chemical reaction. Whether it's homogeneous like salt water or heterogeneous like soil, mixtures are everywhere. Just look around. The air you breathe, the food you eat, even your shampoo, it's all mixtures. And this is just the beginning. Coming up next, we'll explore the fascinating world of solutions, suspensions, and colloids, the real stars behind many everyday mixtures. So stick around, stay curious, and let's keep learning together.